Alright, so let's take a look at the existence and uniqueness theorem, this time for nonlinear first-order ordinary differential equations. So I'm just gonna do the theorem in this video, and in the next video we're gonna look at some problems that are going to we're gonna look at determine which interval in which the initial value problem is certain to exist, or state where in the where in the ty plane is this theorem satisfied, and we're going to look at differences between linear and nonlinear basically in the next video. So for this one, let's just look at the theorem. So this theorem states if we have an IVP, it'll look something like this. Y prime is equal to f of ty. F is a function of ty. And then we have y, t naught, our initial condition, right, is equal to y naught. Okay. So the theorem says for first order nonlinear ODE that if f and the partial of f with respect to y are continuous, hope I spelled that right, on a rectangle from alpha, where t is from alpha to beta, and where y is from epsilon to delta, and t naught exists on alpha beta, and y naught exists on epsilon delta. Okay, so let me just let's draw out this this rectangle here. So we're gonna have a y-axis and an x-axis. Well, I guess and a t-axis in this case. So this is our t, and this is our y. Right? If y is from between epsilon and delta, we're gonna have something. We should probably add in negative axes for these. So we can say that this down here is epsilon, and this up here is some delta. So we have this space here that goes across, and we have this space here that goes across. Now we also have t's between alpha and beta. So we can say alpha is here, and beta is over here. And then we draw the lines going up and down from there. So now if we shade this area in here, this area that's here is our rectangle. So what this theorem is saying, that if f and the partial of f with respect to y, the y-axis, is continuous on this rectangle, right? Meaning that it exists everywhere in this, where t exists in those bounds and y exists in those bounds, right? So this is the overview of the theorem. I think it'll make a lot more sense when we in the next video when we look at some examples of applying this theorem to nonlinear ODEs. So be sure to check that out. I'll leave the link in the description, or it'll be the next video in the playlist.